Parent Night. Several faces I recognize from last time. Tonight we're going to focus on what the children have been working on a little bit and what we're going to continue working with. Here are standards. We're going to look at calculating for area and perimeter using word problems and real situations, and we'll see some of those in just a minute. The second thing we're going to focus on is using a line plot to look at measurements of fractions with those smaller, those 1/2, 1/4, and 1/8 units. What I have on the screen is the same thing you have in your packet. So we're just going to kind of work through a few of them, and then we've got some extras at the back for those y'all can practice on your own. Okay. We typically give the children a word problem, and without even talking about what area or perimeter is, we would just see what they think about the word problem. They've been trained to mark the word problems with a strategy called cubing. So we'd read the problem. Mr. McDonald wants to put a fence around his garden to keep the animals out. His garden is 9 feet long and 3 feet wide. How much fence will Mr. McDonald need to buy for his garden? So we train them to read the story. Then they're supposed to go through and find their important information. Well, let's see. I would want them to recognize that we are talking about a fence. And I'd ask them, okay, where is a fence? So where would a fence be? If you're going to fence in a garden, you're going to put the fence in the middle of the garden or around the garden?
Around.
Okay, so the fence is going to go around. So that's a key word. Then we're going to look at some numbers. We have them circle any numbers that they see. So this garden is 9 feet long and 3 feet wide. My question, they would underline it. So how much fence will Mr. McDonald need to buy for his garden? And that hopefully helps them focus on what they're looking for. Not looking at what is he planting or anything like that. We want to know how much fence. And then they would box the what they're actually looking for. And then we could solve this one of two ways. At the beginning of the unit, I would probably have the students take out these area tiles, and I would have them build a 9x3 unit. They did arrays in 3rd grade, so they should be able to put these out on their table and know that there's 9 on a row and there's 3 rows of 9, and that way they could have a visual. So if y'all would like to make one, I can pass those around, but I don't keep them on the screen. So that would be a way I would start the lesson. Then we'd move from actually touching pieces to having them draw it. So I'd ask the students, okay, if it's 9 feet long and 3 feet wide, what shape is Mr. McDonald's garden?
Rectangle.
A rectangle, okay. So then on their paper, they would draw a rectangle. And I try to tell them not to draw it so small that they can't work with their numbers. And then we also teach them to label. So I have my garden. One side is going to be 9 feet. It doesn't matter which side they label. We don't worry about that. So I wouldn't correct a child if they put the 9 over here. It doesn't matter. So it's 9 feet by 3 feet. Okay. Then we go back and we talk about it's a fence. So where is the fence going to be again? The fence is going to be around. I have them take a colored pencil and show me where's this fence going to be. So a contrasting color. My pen's not, there we go. That should have been on the outside, sorry about that. And ask them, okay, I need 3 feet of fence. I need 9 feet of fence. What about this side over here? If I don't put fence here, the animals are going to get in. How much fence do we need here? Based on the information you have.
You're gonna need 3 feet on the other side.
That's right. So we're going to put, and I have them write that in. They're up here. Did you pass that back? Thank you. Okay. Is our garden fenced in yet?
No.
Still not fenced in, so we have to get this measure. So what would this be? 9 feet. And then we would go back, we also would mention that they know characteristics, properties of rectangles, that opposite sides are always equal length. We tie that little bit of geometry in. Hello, come on in. There's the sign in. Here's the Okay, so we've got our numbers down, and now we're trying to figure out how much fence he's going to need. 3 feet of fence. And I don't have them write the units once we're doing the math part. They can go back and put that in their answer. What am I gonna do with all these numbers? If I go to Lowe's to buy my fence, add them up. Why am I gonna add them up? You're right. Okay, and I need that many sides. If I only do 3 sides, but I don't have a fence, do I? I don't have a closed-in fence. So 3 feet plus 9 feet. And even though they could do that math in their head, we would require them to write those numbers out because they're showing us their thinking. 3 plus 9 plus 3 plus 9. Our answer is going to be in feet, but they always need to include their unit. If you chunk it together, 3 and 9 is 12. And this 3 and 9 is 12. And 12 and 12?
24.
24. And then I would expect them to write out what it is. A lot of times they'll do all this beautiful math work and they'll come up with a number. And they sometimes will not, they don't know what that number is. Is it $24? Is it 24 feet of fence? Is it 24 squares? So we try to get them to go back to the story and write down what we have. So that would be a basic lesson in calculating perimeter from a word problem. And on this, I would not want them to ask me, is this where we're doing perimeter or is this where we're doing area? They need to know from the story what makes sense. Where is that fence going to go? Okay, the next one on your sheet is another math story. Oh, sorry, were there any questions on that one? I think yours is actually the second problem. Is that right? Okay, so we have a story again. Sandra wants to put down new tile on her bathroom floor. Her bathroom measurements are 6 feet wide and 8 feet long. So once again, we have these measures in here. How much tile would she need to cover the floor? So we'd have a conversation about that. Think about a floor. We put down tile. Probably ask them, does anybody have tile in their bathroom? You know what I'm talking about. We point to the tile over here on the floor. Okay. Are we putting tile around the edge of our bathroom, or we want to cover the bathroom floor? We want to cover it, and we would make sure the children understand covered. And once again, we could go back to these tiles, and they could actually put them out on their table if the numbers were smaller than that one is. They could lay out a model to actually have one to look at. Okay, so we're going to cube our story. All right, start with the, I'm going to catch the question first. How much tile will she need to cover the floor? Keywords or numbers, 6 feet wide, 8 feet long. A while ago we had the word fence, so we knew that was going around. What's the word in our question that's going to give us a clue that we're doing this with the tile? We want the inside space. What do you see?
Tiles.
Okay, the tiles. What else?
Cover.
Yeah, cover. We're going to cover the floor. So that would be a key word. We have, once again, draw a model. Oops, sorry. If I have a length and a width, what shape am I going to end up with again?
Rectangle.
Okay, rectangle again. So we have the students draw another rectangle. Crooked. Put their labels on it. And then think about, okay, we want to put tiles down on a floor. When we were doing the fence, we did this. That's not what that's asking us. So we want to figure out how much space we have in here, because they have to put tiles. And I would have mine shade in, just a real quick shade. We're thinking about this space. We're not thinking about going around the edge, and they have to think through that. There we go. Do I need to worry about this?
Yes.
Okay. Am I going around the edges, or am I trying to find out what's on the inside? On the inside. Okay, that 8 tells me that there are, it would take 8 tiles to go across that side. Sometimes we have them draw this one small, I think I can draw it. Pretend that's nice and neat. Okay. So it would be 8 tiles across this way. How many on this side?
6.
You see my number? I'm in the way. 6. We don't worry about it being exact. And they should recognize that from doing multiplication in 3rd grade and our multiplication arrays that we did for review in 4th grade. So if I have 6 rows of 8, What's an operation I could do with it, sit there and count all those guys?
6 times 8 is
6
48.
times 8, good job. So 6 feet times 8 feet is gonna be how many feet?
48.
Oh, good job. All right, 48. Now here's a little bit of difference. What are we counting? 48 what? What shape are they?
Square.
Square. So your answer needs, the unit needs to be 48 square. And if they gave them inches, but if we don't know, this one's feet, 48 square feet. Where's that shape? So hopefully they make the connection, and we would do more than just one or two. We would work on this for a while. The second part of one of these, it's not typed on your sheet or on the screen. I can't see. We would ask them, some of them will ask, okay, he needs 48 square tiles. There would be a second question up here. It might ask them, okay, if it's $2 a tile, what's their cost going to be? So if we went back and added that as a part of the question, so $2 per tile, what is the total cost going to be?
96.
That would be an extension on this lesson, which ties back into our multiplication we've been working on. So if we had 48 tiles, $2 a tile.
96.
Okay, so we do the multiplication. And we had them put that down since it was a cost.
Times 2.
Oh, I'm sorry. Thank you. The 9. That's
Yeah.
And have them put the dollar sign. Put that one, the ones you have for practice in the back are, they're gonna have that money question. All right, any questions? We're good? This isn't anything kind of the lesson we did last time with the multiplication up here. That was a little more involved, and that was really different to what you may have seen before. This is pretty common way of thinking with our area and perimeter. Okay. Another way students may see area and perimeter is they'll be given a picture model, a tile model. There will not be a story to go with it, and in their job, this time they have to know the vocabulary. The students that are in here were very quick to say that I need to add all the numbers together to get the perimeter, or the area is going to be how much space we're covering. So if they have a picture like this, the strategy we've shown them is write on the paper. So if I'm calculating area, I know the area is how many square units it takes to cover. So then we would have them make sure, some teachers had them actually write the numbers in, and then some just have them put dots so they don't lose their place. We do the dots because that's too much writing. Okay, area, so it would be how many square, I know area is squares. So I just need to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that's all they have to do for that type of question. Would be 24 square units. So that part's pretty dark. That part's pretty easy. Students, what are we going to do for perimeter? What do we want to know? It's asking
Tell
for
them all the
perimeter.
sides.
Okay, so we want to know the distance around the sides. We've talked about the definitions. They've added it to their journal. So hopefully they will remember what we're talking about. Also, I have them use strategies. So they need to pick a starting point. We have typically have colored pencils and things out. And I would ask them, or teachers would ask them to record the length of each side. So that is 1, 2, 3, 4, 5 units. They could just count. They have to make sure they cover, take care of all of it. 2 units. 1. When they come into here, oftentimes when they're doing perimeter, they'll leave off parts. That's why I have them trace it. So that's, you're just counting how many lengths there are. We're not counting actual cubes, it's lengths. So that's 1 length, 2 lengths, 3 lengths. I'm just gonna stay in that green. 2 lengths. Up 2. Over 2. Down 1, 2, 3, 4 units. Into Pound one, all, that's an easy place for them to skip for some reason. They don't wanna get that little a piece when it comes out. I said plus one, I'm gonna come back over here. Over two. Up one. And over two. Okay. They get all that written down.
Wow.
And yes, they would have to write all that down, because I wanna see their thinking. And I'll show you a second strategy after we do that. And then their job would be to add up those numbers. Some students will just start and count straight through, and some will use grouping. They may say, I'm gonna add these two numbers together, these two numbers, and they would go through like that. But y'all count it up. What'd you get?
28.
Oh, I'm in your way, I'm sorry, forgive me. 28, okay.
I got 21.
You got 21. Okay, we'll wait for somebody else to finish, see if we can get a consensus on the correct number.
Oh. So,
I apologize for the not so neat handwriting. Still waiting on somebody to confirm your answer.
28.
Mary, what do I tell you to do? How many times are you supposed to count? Try it a second time. Count it again.
Get your number twice. Okay, so we've got 2 votes for
Confirm
28.
it. Yes.
They could go back and, depends on what we're working on, numbers. They also could put marks on each section like that. So they could go around and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So that would be a second strategy they could use. Good job. Got your 28. So that's 2 strategies they could do for perimeter and area. They just simply need to count the tiles. Any questions on that one?
Yeah.
Yes? Wait a
I
minute.
got confused on that.
You got confused on that one? Well,
You
probably don't
counting
need.
the inside of the box, or you're counting the corners?
Are you talking about, we're doing the perimeter? And that's a good question. That's where the children tend to not go in and back out. That's why these little marks sometimes help them too. Yes, ma'am?
I have a question. Why would you put 3 times and plus the 2?
I didn't. That's a really bad sign that I wrote.
Okay.
I put the plus sign twice.
Because I was fixing
No.
to say.
I don't think it's that eraser in there. Is that what you're talking about?
Yes, because I had no idea why would you
No.
put
Bad
3
handwriting.
times then plus 2. That
Bad
didn't make
handwriting.
any sense.
My fault.
Because there's nothing 2 times.
You're right.
Are we good? Appreciate the participation. Okay, now we're going to switch gears and look at the second standard that was on our list, which is the using a line plot. A line plot looks very similar to a number line, which is a number line. The only difference is it becomes a plot when we record data on it with the X's. The students had line plots in 3rd grade. Okay, story problem might start. Students measured objects in their desk. They displayed their data collected on a line plot. What we need the children to understand the first part is this is a place to record data. So there'd be a group of students, and one student found out that they had an item in their desk that was 1/8 of an inch long. Okay?
Okay.
1, 2, 3 students turned in data that what they found in their desk was 2/8 of an inch long. So the X's represent the student that found that information. Am
Okay.
I saying that right?
Uh-huh.
Okay.
That's the data.
So how many students found an item that was 3/8 of an inch long?
One.
1. 4/8 of an inch.
Two.
2. 6, how about 5/8?
No.
No one found a 5/8 because there's no, and sometimes the kids will say these are votes. Kids voted for these. 6/8,
Two.
2 people, and then 8/8. 1. Okay, 1. So they need to understand that first. We talked about plotting data, and that part they would have done in 3rd grade, but they would not have had the fractions with it, I don't think. Their first question would be, this is where it ties into our fraction lessons now. How many objects were more than 1/2? So our focus is going to be on 1/2. There is no 1/2 on this list up here. So what are the students going to have to do?
Give a fraction.
You know where 1/2 is?
4/8.
They've got to know what 1/2 is.
I got 1/4.
Is it not matching? This is one, yours says 1/4 right here. I can change it, not a problem. Okay,
And then we have one.
I will go back to the 1/2. 1/2 would have been
4/8.
right here in the middle. Okay, so we'll go back to 1/4.
2/8.
We got those tiles that snap together.
That's gonna be in
Right,
our.
one
Towers, right down there. I'm blind.
The students, when we were starting this lesson, have these fraction towers that they can look at. What's it? I think that's seven. Those snap together, they're easier to hold. Fourths and eighths. When we first started, we wouldn't teach equivalent fractions to start with. We'd ask the students to get out materials. These are all available at their desk if we were doing this lesson. And we would ask them, okay, what are we trying to find out? It says 1/4. I don't have fourths up here. So what I'm going to do is take these are broken into fourths, this is broken into eighths. Since I'm trying to find out how many eighths I need to make a fourth, they break off a fourth, stack them side by side, break off the same amount. So how many eighth pieces do I need to make 1/4? Right, 2/8. So now I know, using my model, we wouldn't ask them to do that off the top of their head to start with. 2/8 is the same as 1/4. Those guys are the same. I just proved it with my fraction towers. So now we go back to the question. How many objects were more than 1/4 inch? Do I want to count my 1/4?
No.
No, because it says more than. So I would get them to draw a line on the plot,
6 of them.
and then it's asking you how many are above that. So it would be 1, 2, 3, 4, 5, 6. 6 students found items that were more than 1/4 of an inch in length. Is it not matching up? None of it's matching up?
That does.
My words are not matching your words?
Oh, wait a minute. No,
No?
no.
This one says.
It says how many objects
Okay,
measured
it's a couple
1/4 of
pages
an inch.
back.
Is this out of order? Is that what it is?
I think the line part does. Well, but it doesn't match it up exactly.
Oh, well.
No.
Well, we did that one together on the screen. Sorry about that. What does that last one? Your second question says, how many objects measured a half? Sorry about that.
Two.
The X's are matching.
2.
Okay, so the first question matched, your second question isn't the same. All right, your second question says, how many objects measured 1/2? We would go back to the same thinking, take out,
2.
take out the half, piece that's a half, and we'll make her drag that back out, and then find out how many you needed, so where was half? Right here. Okay, so your second question would be, how many objects measured exactly 1/2? It would have been 2. Because remember, the X's represent the data. This is the numbers they were looking for, and this represents the data. Okay. You don't have the second question, but the students would also be expected to do something like this. If you put all of the objects end to end, what would the total length be? The point in doing this would be to have the students recognize that, okay, this student's length was, their object was how long?
1/8.
Okay, 1/8. And we've worked on composing fractions, putting pieces together, and then decomposing for something else. So this would be putting pieces together. How many students had 2/8? 3. So they would write that down 3 times. So 2/8 plus 2/8 plus 2. Yeah, here we go again. 2/8. How many for 3/8? Plus 3/8 plus 4/8 plus 4/8. No 5. They don't have to record 0 right there. Plus 6/8 plus 6/8
And then plus
plus
8.
8/8.
What would be that question again?
It's what's on my board.
How
you-
many, if the
in all.
students combine
Yes.
their
If
objects?
they lined up all of their objects, how many inches? Good question. So if you put all the objects end to end, what would the total length be?
And because that gets kind of long, sometimes I know my children, I let them do it in their head. 2/8, 2/8, and 2/8 is 6/8, so they record it as 1/8 plus 6/8.
Hey, yeah, you're grouping, okay.
Right, they group that all.
Hey, don't do that yet.
and just record
I'm just
it.
grouping.
38/8.
You know you want to do it in time too?
And then they did this too.
38/8.
We would add all of our.
And then you gotta make it a
Mixed fraction.
Just to make less numbers. Sometimes.
And this is just my grouping.
Too many numbers.
14.
Thank you.
You're welcome.
Let's see, 24.
And they could move it out again. 10 and 14 is 24. I guess they put all those guys together.
14, 24 plus
13,
14.
14. I didn't plan this out real well, I can see that. 14 eighths and 24 eighths.
Okay. With the 8 at the bottom.
38
Or
eighths.
hit it at the top.
Wow.
Then we go back to a question, I'm sorry. We would ask them to try to get us an idea of what is 38 eighths? What are we talking about? Is it more than 1 inch? And of course, they would hopefully would recognize that 8 eighths is an inch. So the students definitely had more than an inch. Not going to go into doing improper fractions and mixed numbers, but that's something else the students would do. So they could have this number and then put it back into, okay, how many holes would that be? And hopefully they recognize they could do their count by eighths. How many whole eighths can you get out of the number? And what would be left over? We're not going to do that.
Wow.
If they want to go back and check, I guess they could they have just straight count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some of them could do that.
Yeah,
But we typically want them to show their thinking
that's kind of why I let them group the tops up, because,
here.
yeah, they just would add all the 2/8, all the 3/8, and then they add
Oh,
them
on the plot.
together.
Okay, I see what you're saying. My brain's not working.
Let's say
So then they would just have 1/8 and then 2
6
more 6
eighths.
eighths. I see what you're saying now. Okay.
plus 3/8 plus 8/8
Okay.
plus 12/8.
And not record all of that.
Yes,
Okay.
then they're still showing me they understand less numbers,
Okay.
less chance for a mistake.
Okay. That's all the presenting we have, but we have a few in the packet that we'd like you to try, at least 1 or 2 of them.